Hi Chelsea, thanks for your question. I'm going to try out some new software that I've been playing around with a little bit and see how this works in terms of making you a video. So this is kind of fun for me. This is the question that you sent me, and the first thing that you want to do is look at the original equation, the 3x squared minus 3x plus 2, and just kind of discern everything that you can from the equation. So right away we know that it's quadratic, it's a trinomial, it's a degree 2, and we know that because it's positive 3x squared that it's going to open up and not upside down as if it were a negative in front of the x squared. So we know all that, and I think you mentioned in your email that the domain and the range you're okay with, and it's just the other things that you're having a little bit of trouble with. So I'm glad that you let me know that you're having trouble. And this is just one method that I have of trying to help you out and explain things. So please keep letting me know whenever you need help with stuff, and we'll always find a way to get through it, okay? So starting over here with the number of local maximum and minimum points, a little bit of logic comes into play first with this, because you have to decide if you're going to have both max and min points or just one or the other. And if you think about the shape of the quadratic equation, if it opens up, you're going to get a parabola like that, and it's going to open up, which means we have one minimum point right down here and no maximum points, because these guys are going to travel on forever in the upward direction, so you're never going to actually get a highest point, just a lowest point right here at the vertex. So also, because it's a degree 2 equation, the number of maximum or minimum points that you get is always based on the exponent of the lead variable here, so x squared, and you subtract 1 and it tells you how many of those turning points or critical points we're going to have. So in this case it's just 1. So in answer to the question, what's the number of local maximum or minimum points, in this case, based on everything that we know about this function, we would answer that there is one local minimum and no maximum points. Now if we look at the end behavior as x approaches infinity and x approaches negative infinity, then all they're asking us to do in that case is really just do a substitution. So if we have the function y equals 3 times infinity squared minus 3 times infinity plus 2, then we can see that that is going to approach positive infinity because we're going to end up with 3 times infinity squared there, which is much greater than infinity, if that makes any sense at all. If we do it the other way and we have y equals 3 times negative infinity squared minus 3 times infinity plus 2, and we're trying to evaluate what that's going to look like, in this case we have negative infinity squared, which is going to change to positive infinity squared because negative times a negative is a positive, and so this one also approaches positive infinity. In other words, the values are getting bigger and bigger as we go to the largest possible value of x and the smallest possible value of x, and so that's all we need to explain for that question. So I hope this helps. It's kind of fun using this new software. Like I said, I've got other things I can try as well, but this was a new one for me. And please have a look at it, and if you have any other questions, just send me a screenshot and we'll try and do it this way and get you through this assignment. And please don't stress, this should be fun, and just think of it as having like a one-on-one tutor, your own personal teacher. Whenever you're stuck, even on assignments that you need to hand in, you can ask me for help, and I certainly will help you, because it's all about learning in this course, not about evaluating and taking marks off and things like that. So all right, I will try to stop this and save it and somehow figure out a way to send it to you. Wish me luck.